Topic 1-2, Integers, Absolute Values, and Properties. On the line that you have on your notes, place a 0 in the middle and label it with the markings on the line. Do the same for both sides and label the left side of 0, label these negative numbers. And then on the right-hand side of 0, these would be your positive numbers. Then place a 3, actually I have all the numbers, but I'm looking at the notes here. Place 3, 3.5, and 4 on the number line. Well, 3.5, I haven't labeled that yet, is halfway between 3 and 4. So 3.5 would be here. A negative 3.5, since this is negative 3 and negative 4 between, this would be where a negative 3.5 would go. Okay, so that's how looking at numbers in our negatives and our positives. So let's look at integers when they're mentioned to us in words, how they would actually be annotated as numbers. 3 degrees below 0 would be written as negative 3. It says write the integer for the following and then write its opposite. So the opposite of a negative 3 is a positive 3. If $20 was lost trading, that's going to also be negative 20. Its opposite would be positive 20. 50 feet above sea level would be marked as a positive, so its opposite would be negative. 10 yards gained, that would be positive. Its opposite, negative 10. A bank deposit of 500, if you're depositing, you're putting it into the bank. So a deposit would be a positive 500, where its opposite would be negative 500. Absolute value is the next thing we're going to look at, and it's the number that shows distance on a number line. So looking back up at your number line, whether you're at a negative number or a positive number, since absolute value only describes distance, oops, I meant to highlight that, distance, then, let's just do that again. The absolute value is a number that shows distance. So that's what we're looking at here. So looking at numbers that show absolute value, they're shown with these bars. They're shown right here and on this side of the 9. On this side of the negative 17 and on this side. So just remember that you're looking at this bar right here on each side of the numbers denotes an absolute value. So again, we're trying to remember that it's distance that you're looking at, and it's always, always positive. So if 9 is inside an absolute value bar, it is a 9. If a negative 17 is inside, it's also positive. This one's trickier because the negative's on the outside. It means the opposite of whatever the absolute value of negative 8 is, which that's actually going to be a positive 8, but since it shows the negative, you have to point out that it's the opposite of it. So that one you might want to star. That one's a little tricky. Okay, 14, a negative 4 absolute value is 4, plus a 3 absolute value is 3. So your final answer for this one would actually be 7. Okay, continuing on to the next page. 15, this is an absolute value of 12 minus 3. Well, if 12 minus 3 is 9, and the absolute value of 9 is always positive, then your answer would be 9. The absolute value of 8 minus the absolute value of negative 3. So you're looking at the absolute value of 8, which is 8, minus the absolute value of a negative 3, which is 3. So here you're looking at the answer being 5. Again, we have 3 times the absolute value of a negative 4, which the absolute value of negative 4 is 4. You got to remember that any number next to it means a multiplication. So that one would be 12. Okay, this one's a little bit trickier. You just have to make sure you compute the absolute values first. So this is going to be 2 times 5 minus the absolute value of negative 6, which is a positive 6. We've learned in our previous lesson order of operation, we're going to actually make sure to do the multiplication first. So if you're multiplying first, 5 times 2 is 10. 10 minus 6 is 4. Okay. Looking at number 19 through 23, we're looking at comparing numbers. So here they want us to compare using less than, greater than, or equal to. So in reading inequalities, you're reading it from left to right. So in order to decide whether that's a greater than or less than sign, in this case we're reading from left to right. So this is going to be a less than and this is going to be a greater than sign. So how does 5 compare to 8? Well, 5 is smaller than 8, so our sign's going to go this direction. A negative 3 and a negative 9. Always remember your number line. If you go back to the first page and see, a negative 3 is actually greater than a negative 9. And since this is absolute value, we're looking at the absolute value of a negative 4, which is 4. And 4 compared to 4, those would be equal. Negative 7 and a positive 7, less than. 1/2 is actually greater than a negative 5. Okay, kind of a quick review of greater than, less than, inequality signs. We'll probably see that again in later units too. We'll go over that again. All right, now you're looking at properties. We're going to be going through properties throughout algebra, and these will need to be just pretty much memorized, especially the commutative property, associative property, and distributive property. Commutative, if you look at the example, A plus B equals B plus A. A times B equals B times A. All they've done is switched the position after the equal sign of the two letters. Associative property, look closely. What they've done here, let me get a different highlight color. Let's go with blue. Here what they've done is they've associated this A and B, and they didn't change the numbers like in commutative, they just changed where the parentheses were. So the parentheses moved places from A to B to C. Notice this is a property of addition, associative property of addition, and this one is associative property of multiplication. Okay, this is different than what you're looking at in distributive property. Distributive property, if you've got A times B plus C, what you're doing to distribute that is taking your A and multiplying it by the B, and then taking your A and multiplying it by the C, shown here after the equal sign. The same thing's going to take place in multiplication, even they've shown some with subtraction also. So just remembering that distributive, you're multiplying by the outside of the parentheses to what's on the inside of a parentheses. Distributing is the key word here in multiplication. And leaving, always make sure you're leaving the addition or subtraction sign that they're showing here and here. Okay, on the last page we're naming the properties that we've just gone over, and I've gone ahead and put the names here, but let's go through and just look at the reasons why. Notice on number 19, 7x plus 8y, all they've done was switch the 7x to the outside and switch the 8 to the inside. So that's just switching them around. That's just commutative property. Distributive for number 20 because R is multiplied by 3, and then it's multiplied by the 4t. All right, look at 21. The only thing that's changed here was they've moved the parentheses around the 6x and 9 to the 9 and the 7y. Associative property, you're not moving any of the numbers on either side of the equal sign, you're only moving the parentheses. The next one is associative also because notice the numbers didn't move, only the parentheses moved. You're associating what to do, the operation, with different numbers. But they're still in the same position. Okay, looking at number 23, this one's commutative because they've actually moved the 6 from the first all the way to the outside. And then they moved this whole grouping to the inside. Commutative also here because notice the 2b stayed in the same position, but they've switched the 5 and the 3a inside the parentheses. They didn't switch the parentheses, they just switched what was inside. And then the very last one is distributive because they're multiplying that 15 times an a and then multiplying the 15 times the 4. So that concludes that lesson. Go and try some on your own.